Alright guys, the circles assignment in the chapter involves a graphics file, a graphics library, which if you weren't able to find it to download it, I've attached it as a zip file so you can find it there. It's also in contents under libraries. If your textbook refers to it as easy graphics, I misspelled it, it's not supposed to be easy graphics. I'll fix that. Anyways, it's just now called graphics, not easy graphics. So if there's like an import statement that says import easy graphics, it's just import graphics. All you need to do is download it, extract it, and then copy that PY file into the same file as the code you're currently editing. So we were looking at chapter 4, I believe. When you define a function, some languages have a differentiation between the term function and procedure. Not any that I've used recently, but it was a useful distinction. A procedure is something that didn't return a value, and a function was. Nowadays, everything's a function in this language. So function is a block of code with a name. It can accept arguments, which are variables that get I think I'm just going to say it can accept arguments. It can return a value. Now Python is the only language I've ever seen where you can actually return more than one value. I'll show you what I mean. I'm just going to start an idle window. I don't care if you type this or not because this is mostly a curiosity, but I personally don't take advantage of this. Say you wanted to do this. Define my function, MYF. And what does it do? It returns Donald, comma, duck, comma, is, comma, funny. And then down here you could do A, comma, B, comma, C, comma, D equals my function. And then if you print those things out, print A, comma, B, comma, C, comma, D, it's going to print Donald Duck is funny. So I'm going to save this as September 12th. And says Donald Duck is funny. Now, the vast majority of languages only allow you to return one thing. You could not return 4 different things. Define my2, which is going to return 100 and the word hello. And so you could call my function 2 like this. Number, comma, word is equal to my2. And then you could print those things out and it would print 100 hello. That's really kind of strange. I'd recommend writing every function so that it returns one and only one value. That also means you can do things like this. This is kind of odd, but it doesn't even involve functions. But you could do this. A is equal to 100, B is equal to 200, and you could do B comma A is equal to A comma B. That just reverses the values. When you're done with it, B now equals what A used to have, which is 100, and A now equals what B used to have. Do I do that either? No, but you can. Pretty odd. On the other hand, you might argue, well, why don't more languages support returning multiple parameters? Maybe someday they will. Python is newer than Java and C# and C++ and things like that, so maybe so. So what is an argument? An argument is a value that you pass into a function. If you do this, x is equal to, we're going to round off the number 123.456 to 1 decimal place. And then let's print x. The round function will take this number and round it off to 1 decimal place, as long as I remember my syntax correctly. Yeah, so print it out 123.5 because it rounded .456 to 1 decimal place. These are what are known as arguments. That's an argument, and that's an argument. When you define a function, if you want to pass arguments to it, you have to define parameters that catch those arguments, that accept those arguments. So define say hi. I'm going to create a variable called name. Since it's a variable between the parentheses, it's called a parameter. And you can print hello, comma name. And when you invoke it, say hi to Fred. This is the argument. This is the parameter. The parameter gets a copy of that value, and so it'll say hello, Fred. It's pretty important to remember that Python, like a lot of languages, is pass by copy or pass by value. Meaning that if this function changes the value of name, it's no longer going to be Fred, it's going to be Lucy. That doesn't mean anything as far as what's coming down here. Nothing got changed outside of here. This change only took effect for this block of code. Yes, if we printed name out here, it would be Lucy. But let's say we create a variable that contains a name and then we called say hi. So like n is equal to Bob. And then we call say hi with n. And then we print out n. You might think, and it's not a completely unreasonable assumption, that since we are changing the value of the name parameter to Lucy here, that by the time we print it out here, it would be Lucy. But no, it's still going to be Bob, because this is just a copy of what was passed in there. So it's the string Bob, and if we change it to something else, great. It doesn't change the variable itself, it just changes the data that was copied. So when we say pass by copy or pass by value, it's like I photocopy a page before I hand it to you to do something. So then if you go and you tear that page up, great, I still have the original. This is the original. Changing it in here doesn't change it there. Which means, how would you change it? How would you get that value back? Well, you have to have a return statement that would return something out of it. You're about to ask?
I was just going to ask, I get what you're saying, but it's almost like when you pass that parameter in, it goes, okay, second line, print hello, name. It looks to the line right above it, which parameter you passed into.
Right.
And so Lucy just like never even gets to Lucy.
Right. If we stuck out one more print statement here, then it would print out Lucy there, but this is going to be the original value. Exactly. Yeah, we weren't even using that variable. That was an unused assignment there. It was having no effect at all. So we can add our own functions, as you just saw. Define print lyrics. I'm a lumberjack and I'm okay. So the flow of execution. We've talked about flow of execution, I believe. The 4 types of flow of execution. I'm going to put 3 quotes here to start a long comment. There's sequential statements. There's conditionals. Some people call them decision. Some people call them branches. Those are just your if statements. If and if else. If, elif, and else. Then you have your loops. Those are your while statements. And then you have your function calls. back in the 70s and before, programming languages supported a command called goto. And you can still find some support for that in some of the C-based languages and stuff like that. But goto is strongly frowned upon because you could have, 100 lines of code and then it would say go to line number 9,000 and it would jump down there and it would do some stuff and it'd say go to 300 and you would run up there. And it was impossible to figure out what it was going to be doing. So function calls are the way you get code to go to something else. So this is running here. This gotos, that function, it does some stuff, whatever the block of code is, and it comes back. So it's like you're following a recipe and the recipe says, now go ahead and make a cup of hollandaise sauce. You're supposed to flip in your recipe book, find out how to make that sauce. You finish that and then you turn back and you keep going. So that's a function call. Otherwise, everything is sequential, right? Top to bottom. Everything that's unindented is what gets run first. You find an unindented statement, that's the first thing to execute. Ta-da. It starts running there. These just set up things that can be called. They're like putting pages in the recipe that show the hollandaise sauce being made, but we haven't made it yet until we call that, or until we call that. So sequential statements, then there's the conditionals. You have your if condition, then do some code. So conditional code is executed based on a decision or not. And then you have your loop, which is how you repeat certain pieces of code, get them to work over and over and over rather than just copy and paste that code 100 times if you need it to be run 100 times. So function calls, like a detour. Rather than go to the next statement, the flow jumps to the body of the function, executes all those statements, and then comes back in where it left off. Sounds simple enough until you remember that one function can call another. In the middle of one function, the program might have to call another function, and then that program could call another function, and so on. While executing a new function, the program might have to execute another function. Fortunately, Python is good at keeping track of where it is. Each time a function completes, the program jumps back to where it was before the function was called. And then when it gets to the end of the program, it terminates. What's the moral of this sordid tale? When you read a program, you don't always want to read from top to bottom. Sometimes it makes more sense if you follow the flow of execution. It's a weird statement, but okay. Parameters and arguments. Here we have a function called print twice. We have named our parameter Bruce. So whatever we pass in there gets printed twice. So we call it, we print it spam, it's going to say spam spam. We call print twice with 17, it's going to print 1717. This language, unlike many, is weakly typed, meaning that you don't have to specify a data type for this parameter. Some languages let you say, okay, print twice accepts a string, and that's the only thing it can accept. In which case that would work great, and that wouldn't even compile because we were trying to pass an int to it. Python's not that picky. We import math, we call print twice with math.py, and it would print pi twice. So we're seeing 3 different data types being passed to it. The same function worked with a string, and worked with an int, and with a float. Are your functions always going to work like that, where they can accept any data you pass to it? Well, probably not. What if you write a function that calculates the square root of something, but you passed in spam? It's not going to work. So fruitful functions versus void functions. Let's see what a function returns if it doesn't return anything. Go back to our code. I'm going to write a function that doesn't return anything. Define nothing. Whoops, I'm still in my comment. Let's get rid of the comment. 3 more quotes. Let's print a message. I return nothing. Okay, I'm going to make that U and O just so people don't think I don't know how to spell. All right. And then down here, I'm going to call nothing, but I'm going to set its return into a value. So x is equal to nothing. Print x. And that's what we get. We get the word none out of it. It's just not returning anything. But rather than return absolutely nothing, there's a value type called none that it returns. Something that returns nothing is called a void function. And then you have fruitful functions. Fruitful meaning that they do return something. They will have the return word. Now, even when I write a void function, I have the urge to stick the word return on there, just because I think it's pretty. I like looking at it like that. Do you got to? No, the first unindented line is the end of that function. But on the other hand, the word return very clearly marks the end of the function. But anyways, let's do a fruitful function. Define breakfast. We're going to print something, time to eat, and then we're going to return eggs and ham. Not ham, ham. So then if I do x is equal to breakfast, x equals breakfast, and then I print x, it's going to print out eggs and ham. Because whatever was returned out of here, when the breakfast function is done being called, whatever was returned fills in that variable. Eggs and ham. So that makes sense. A void function is something that doesn't return anything, and a fruitful function is one that does.
So I have a question.
Yes.
On the void function, what was it about the syntax that caused it to print the value none versus the print statement I return nothing?
Well, it did print I return nothing.
Okay.
It just didn't
Right,
pass
I see
anything
that.
back.
Okay.
Right. Or pass back a special value, none.
Gotcha.
Yeah. If you want to, you could return something out of every function you write. You could return a zero.
Is that because there was nothing on return right there, whereas down below we had an actual string?
Yeah, if I stick return here but I don't put a value, we're still going to see the word nothing there.
Gotcha. Okay.
Or none, I'm sorry. None is just the special value that Python in particular returns if there's no return value. Other languages don't pass back anything at all. You just know. And you'll get a compilation error if you try to do that because you're setting x equal to nothing.
Right.
But in this case, you can set it. It's just going to be the word none.
Well, I
Let you.
guess it's kind of helpful in a way because if you're running your code, you go through and you see that, and you're like, oh, I forgot to put a value in there.
Exactly, right. Yeah, you could use that for debugging purposes or whatever. If you ever see the word none there, you know you tried to store a return value that wasn't actually there. So like I said, you can stick the word return there. If it doesn't return anything, it's a void function. If it does return something, it's a fruitful function. If you want to see what none is, let's go to the Python shell and do type of none. It says, what do you know? Class of none type. Whatever. But you could use that yourself if you ever want to do a is equal to none. I don't know why you would do that. Cannot think of a reason why. So we can make a simple function called add2 that adds two numbers together and returns a result, just like that. They've defined a function. Whoops. It accepts two arguments. Those arguments are stored as parameters a and b. Added equals a plus b, return added. So we do x is equal to add 2, 3 comma 5. Those two numbers are added together, returned, and so when we run it, it'll print 8. But that's all well and good, but how, when you're ready to edit your code again, do you get back to it? All right, hit the pencil. So why use functions? Creating a new function gives us the opportunity to name a group of statements, which makes your program easier to read, understand, and debug. Functions can make the program smaller by eliminating repetitive code. Later, if you make a change, you only have to make it in one place. Say we write a turtle program that's going to draw 8 squares and we decide later on that we wish they were triangles. Well, if you put all 8 of those squares in a single function, then you could just change that one function and it would change all the triangles. Dividing a long program into functions allows you to debug the program one at a time and then assemble them into a working whole. Well-designed functions are often useful for many programs. Once you write and debug a function, you're done. You can save it as a PY file and then you can use import and bring it into something else. So throughout the rest of the book, we will often use a function definition to explain a concept. Part of the skill of creating and using functions is to have a function properly capture an idea. Something like find the smallest value in a list of values. Later we will show you code that finds the smallest value in a list of values, and we will present it to you as a function named min. Well, there already is a min function. So debugging. If you're using a text editor to write your scripts, you'll run into problems with spaces and tabs. The best way to avoid this is to use spaces exclusively. Well, blah, 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 blah. Alrighty. So what is an algorithm? It's a process for solving a category of problems. I really don't like that definition. An algorithm is a series of steps to follow to solve a problem. How do you calculate pi? There's an algorithm for it. An argument. An argument is a value that you pass to a function. It gets assigned to a corresponding parameter. The body. The body is a sequence of statements inside the function declaration, everything that's indented in a function. If statements also have their own body inside the if statement. Composition. Use an expression as a part of a larger expression. I'm going to have to scroll back up and see why we said that. Composition. Whatever. Composition is taking a formula and expressing it as code. So if you have this line of code, A is equal to 3 plus 4 over 5 plus 6, and then in front of it all was X, like that. You saw that in a textbook. You would know what that means. It means A is equal to X times 3 plus 4 over 5 times 6. So composition means turning that into computerese. Might not be as easy as it looks. Here's what we can't do. Whoopsie. We can't just do this. A is equal to X, 3 plus 4 divided by 5 plus 6. That's totally wrong. For one thing, books leave out multiplication symbols when they can. We have to assume that that's there. So we could go down there and do that. But is that still correct? No, it's not correct because we need to put parentheses around that, and we need to put parentheses around that. So then we would go and do that and do that. So composition is using operators to create expressions that solve a formula. I'm not going to ask you the definition of composition. Use an expression as a part of a larger expression or a statement as part of a larger statement, which we've done. That's an expression that's part of a larger expression. So is that. All of that is an expression. Technically speaking, even a single variable or constant is an expression unto itself. Generally, though, you mean as an expression as a series of operators and operands. Dot notation, the syntax for calling a function where you specify the module name followed by a dot. So if you want to print out pi, I believe we added import math and then we printed out math.pi. Let's see if that works. Import math, print math.pi. And it printed it out to like 15 or 16 places. That's the dot notation. That's why you can't make dots as part of your period, part of your variable names, only underscores. Dividing a program into functions allows you to debug it one part at a time and then assemble it. And a well-designed function is often useful for many programs. Once you write it and debug it, you can reuse it. Just save it as its own file. Import it when you need to. Wait. I'm reading the same thing I had before. Okay. So fruitful function is one that returns a value. The flow of execution is the order in which statements are executed. A function is a named sequence of statements. It's a block of code that has a name. It's supposed to perform a useful operation. Might or might not take arguments. Might or might not return a result. Function call is when you invoke that function. You put the function followed by the parentheses, followed by any necessary arguments. Defining a function, we know how to do that now. The def keyword followed by the name, followed by any arguments, and then a colon, and everything else under that, it has to be tabbed over. The function object, a value created by a function definition. The name of the function is a variable that returns. I'm kind of iffy on that. I'm going to leave that one alone. The header of the function, that's the first line of the function definition. So when we did say hi, def space say hi, parentheses name, in parentheses colon, was our header. We know what an import statement is. Reads a module file, a py file. We haven't talked enough about these module objects. I don't remember hitting that term very much in these previous chapters and online. Certainly not in the book. I'm going to have to go and read more about them. The parameter is the variable that gets the argument, the value of the argument passed to it. Pseudo-random. Pseudo-random is a random number, but it's generated by an algorithm. So if it starts with the same seed, it'll always be the same sequence of numbers. Be like if you bought a deck of cards, but it was sorted in a specific way, and every time you played it, it was still sorted that exact way, then the game would not be very challenging. You would know pretty much what cards everybody was drawing. Exercise. What does the following program print? When we call Fred, it prints Zap. When we call Jane, it prints ABC. So, Jane, Fred, Jane. What is it going to print? It prints ABC, yeah, followed by Zap, followed by ABC again. So ABC, Zap, ABC. Hopefully that's the correct one. All right. So I said we were done with chapter 3, and there was something that I wanted you to read in it, but that we didn't actually cover in class. The functions for the string operations, for testing substrings. So I guess we have September 6 here, or September 12. I'm just going to make a new one and call it September 12B. So string functions, or string operations. There's the word in. The syntax of it is something like x in y. Returns true if x is in fact part of y. So print is Fred in Fred Flintstone. Probably will be. Yep, that's true. Let's see how many times the word Fred is in Fred Flintstone. So, let's make a string that contains Fred Flintstone. Well, we don't have to. This is a weird syntax. Let's just count how many E's are in it. Fred Flintstone dot count how many E's are in there. But let's store that in a variable so we can print it out. Print X. So Fred is in fact in Fred Flintstone. And when we counted the number of E's. Now, do I like doing that? Do I usually hard code a string and then call a function based on that string? No, but I've seen a lot of textbooks that do, and it drives me up the wall. I don't like that. What I would instead do is do something like name is equal to Fred Flintstone. And then I would do x is equal to name.count E. And print x. Again, it should be 2. I just mention this because you'll see examples of that on the internet. It bugs me. Not very many other languages let you do that. Define a string on the fly and then immediately start calling methods, which are functions that are attached to data based on that string like that. Then there's begins with and ends with, or starts with. If, and you don't need the parentheses, name dot ends with stone. I'm going to take those parentheses out. It's not Java. Print, yep, it ends with stone. How about if name dot begins, or starts with, starts with rock, print, yep, starts with rock, else, colon, print, nope, doesn't start with rock. So it did end with stone, sure enough, but it didn't start with rock. And then along with the in function, in, there is dot find. Say I want to find the position of I in that name. So x is equal to name dot find, and tell me the position of the I. One, 2, 3, 4, 5, 6, 7, 8. I forgot to count at 0. Computers always start counting at 0. 0, 1, 2, 3, 4, 5, 6, 7. So when it runs, it should say that the I was found at position 7. What if we try to find something that doesn't exist? Change that I to a Z. Returns -1, indicating it doesn't find it at all. So let's list our functions so far. X and Y returns true if x is a substring of y, or if they equal. If you did this, don't type this, but if you did if Fred in Fred, yeah, it can find Fred inside Fred. That would also be true. And then you have count x dot count y, counts how many times y is in x. And then you have x dot begins with, nope, starts with y, returns true if x starts with y. X dot ends with y, returns true if x ends with y. And then the last one, dot find. X dot find y. This one takes a little bit more explanation. Returns the index value of y in x, or -1 if y not found in x. And most of these work with lists as well as strings. If we define a list and then we check to see if something is in that list, we use the word in. If we want to find something in that list, I believe we can call dot find on it. And then there's a whole bunch of functions for testing string characteristics. Is something uppercase? Is something lowercase? Is something a number digit? So let's just mark that we need to know these. I think I'm going to start a multi-line comment again with 3 quotes. Just know is alnum, s dot is alnum. That returns true if s is either a digit or a letter. True if s is all digits or letters. S dot is alpha returns true if it's all letters. True if s is all letters. S dot is digit. To me it's weird that they call this one num and digit here, but I didn't make the language. True if s is all digits, all numbers. Bless you. And then all lowercase and all uppercase. Is lower true if s is all lowercase letters. S is upper. True if s is all uppercase letters. And if you took my 1, 1, and 3 course and maybe some others, we wrote a password program to investigate to see if the password met the criteria. You know.
Is there one for spaces too?
Yeah, there is. It's is space. See if I'm forgetting any others. 1, 2, 3, 4, 5, 6. Yep, and is space. S dot is space. True if s is all white space, meaning tabs and spaces. So let's write a little bitty program to ask them to type something. And then it'll print out if there are letters in it or if there are digits and if it's all lowercase and if it's all uppercase or if it's all white space. So S is our string. S is equal to input, type a word or number or something. How's that for vague? Now let's do a whole bunch of if statements. If s dot is alnum, colon, print all numbers or digits. Now, I'm not going to use elif because these are not mutually exclusive conditions, right? It might be all letters and it might be all lowercase. Or it might be letters and it might be all uppercase. If this is true, you know, then that one could be true or that one could be true. So I'm not going to use elifs, I'm just going to use ifs. If s dot is, that was supposed to be alpha, not just alf.
Show.
Yeah. Lock up your cats. So s dot is alpha colon print all letters. Why did I write all numbers or digits? Those are the same things. How about all letters or digits? I need to change that line. If s dot is digit. Now the problem with is digit is that I wish it would count a single period as a digit, but it doesn't. So if you do is digit on the string 3.14159, it'll say no, it's not all digits. Oh well. Print all digits. If s dot is lower, print all lowercase. I'm curious to see what happens if you type like an lowercase letter, lowercase, and then followed by a 1. Does it count that as being all lowercase? Do digits count as lowercase? Probably not. Two more if statements. If s dot is upper, print all uppercase. And then lastly, if s dot is space, print all white space. All right, type a word or something. HELLO with a capital H. It says it is all letters or digits, and it's all letters. Let's run it again and type hello in all lowercase letters. It is letters or digits, it's all letters, and it's all lowercase. How about if we type A1 lowercase a, does it say it's all lowercase? Yep, actually it does. What do you know? All the letters in this thing are lowercase, even though there's something that's not a letter. All the letters are indeed lowercase. I learned something new. I didn't know that would work. So you really do need to remember these 5 things and then these 6 things from chapter 3, how to use them. A common way to use them is to process a string letter by letter, counting how many digits there are and how many uppercase letters and how many lowercase letters and so on. Maybe we'll loop back to the idea of a password program. Try not to repeat too much straight out of 1113, but I know that people have taken other 1113 classes besides mine. So here's where it gets a little bit weird. Do I base any homework on what we've covered on the online textbook, or is it all based on the written textbook? Should I give it a homework assignment where we talk about functions right now, because we already have talked about them on the online textbook? Or do I wait until you hit chapter 5? I say we go ahead and do some homework on that. I'll just have to create a new folder. Okay, so what I want you to do is going to be to write 3 functions that do the 3 conversions of my choice, and I haven't given you those conversions. And I'll give you some examples, and then we'll have to end pretty soon. All right, so let's write a function that converts from Celsius to Fahrenheit. The formula for C to F is F is equal to C plus C times 1.8 plus 32. So we'd have to pick a good name for the function if I don't tell you. Define, what could we call this? Convert temperature wouldn't be good enough, because what if I asked you to convert from Celsius to Kelvin on the next one or whatever? Yeah, yeah, let's do convert CF, like that, from Celsius to Fahrenheit. Does it need to take an argument? And I would say, yeah. We need to pass a number into it so that it can manipulate that number and return it back out. So I'm just going to pass in a variable called F, which is a temperature F. And then we, no. Pass in a temperature in C. Why don't I actually spell out the whole word? And here's our formula. Temperature in F is equal to C times 1.8 plus 32, except it's not called C, is it? It's called temp C. And then return that value. Bless you. Now let's write another one. Function that converts from pounds to kilograms. The formula of which, well, more than one way to do this. 1 pound in kilograms okay, if we're going to get super precise. Formula is kilogram equals pounds times that. So, define, convert P to K, pounds to kilogram, LBS to K. And what we're going to pass in are the pounds, because we're converting from pounds to kilograms. And then we need to execute our equation. Kilograms is equal to pounds times that number, 0.543592. And then we've got to return that. Yes, I do. For, what did I type? 53592. I didn't do it again, did I? Forget it. Copy and paste. Y'all can type it. I can't, apparently. Alrighty, there we go. 453592. And then you want to test it out. Temperatures are real easy to test out as long as you remember that. I hope so. Whew, thank you. Okay. As long as you remember that 0C is 32F and 100C is 212F, then testing that is real easy. But let's go ahead and do so. Let's get temperature in C is equal to input. What is the temp in C? Then we need to convert it to a float. Temp C is equal to float temp C. And now let's get the temperature in F. We're going to call our function convert CF. Temperature F is equal to convert CF. We're going to pass in temp C as our argument. And now let's print out our results. Let's do it with a fancy print statement. Print the temperature percent F in C is percent F in F. Looks a little bit weird, but it's okay. I think we've already talked about what the percent signs mean. These are placeholders that are going to get filled in with the next chunks of data we pass in. We have two pieces of data to pass in, though, so we need to pass them in as a pair of items into parentheses. So percent temperature C, comma, temperature F. I'm going to take the word the out so that it all fits in one place. And I need one more closing parentheses. All right, do you have to make a complicated print statement like that? No. You know what a simple one looks like. If you want to go for that, that's cool. Let me check and make sure this actually works. So 0 degrees C should be 32 in F. What if I don't want that many decimal places? How could I shorten the number of decimal places?
Put a decimal on a number.
Right, I'll put a decimal here and make it like 0.2F. That'll mean 2 decimal places, 0.2F. I'm going to take those words in out, just so it's all okay. Let's do the same for kilograms. Now, I don't have any measurements for kilograms quite so nicely memorized because it's obviously a less precise. Well, it's a very precise. But you can say that roughly 1 kilogram is 2.2 pounds. So if we run it and we type in 2.2 pounds, it ought to be about 1 kilogram. Let's do that again. Let's do that. So if we're converting from pounds to kilograms, we need to ask them for how many pounds. Pounds is equal to input. How many pounds? Then we have to convert it to a float. Pounds is equal to float, pounds. Then let's call our function. kg is equal to convert pounds to kilograms, passing in pounds as our argument. And then let's print it out. Print %.2f pounds is %.2f kilograms. End quote, followed by a percent sign, parentheses, and a pair of values. Pounds, comma, kilograms. I don't know why I like to put an S at the end of pounds, but not at the S at the end of kilograms. So 2.2 pounds ought to be about 1 kilogram. There we go. So that conversion worked. Okay, so I'm going to want you to write 3 functions. Let's see if the convert, I'll bring that code back up in just a second. Nah, don't want that one. Alrighty. So here's the function. Write functions to do the following conversions. Feet to inches. That one's pretty easy. It involves 12, right? There's 12 inches in a feet. Miles to kilograms. Not kilograms. Kilometers, right. Miles to kilometers. And we did C to F, right? So temperature in F to temperature in C. Have your program prompt for a number of feet and use your function to calculate and display the number of inches, and so on for the other two. Have your program prompt for the number of miles. So on. And lastly, have your program prompt for the temperature in F. And use your function to calculate and display the temperature in C. Look up the formulas. If you get stuck, text me and I'll give you the formulas. Because it's not a math class, I expect you to know how to write functions. I don't expect you to have burned into your brain how to convert miles to kilometers and vice versa. I think it's 1.69 miles per kilometer, vice versa. Whatever. Okay, so that'll be the homework assignment. Are there any questions over what we did today? This will be due in a while. I mean, we have still the Chapter 3 assignments coming up. If you need more time because you couldn't find the graphics.py file, when you upload it, just say, I couldn't find the graphics.py file. Don't count me as late. And I probably won't. I guess I could slot this in as Chapter 4, but I'll have to specify that as Chapter 4 online. All right, guys. We need a Dropbox for today, don't we? Dropbox F. String functions and functions, strings and otherwise. And if you have to miss a day, it's okay. Just watch the lecture. It's okay if you have to turn in a short assignment late because you don't watch the lecture the same night it was posted. No biggie. There are a lot of students taking this class in online, and I just asked them to get the in-class stuff uploading, 3 days of the lecture being posted. If you're going to be gone for a week, whatever, just let me know. All right, if you refresh your Dropbox, you'll see homework F. I guess we're done. Anybody need any help? Okay.
Put the code back
Go
up.
back up? Sure thing. Which part do you need to see? The function definitions or the stuff underneath it?
The stuff under that one.
Okay, okay.